In this lecture, we will talk about some real-world scenarios in which SQL could help us do the real production work. In the first example, we want to check the data quality of a column, AQS preference. In this SQL statement, we use the aggregate function count1 together with group by. By using count1, we can count the records that have no value in the column. If we do not use count1, instead, if we use count the column name or count AQS preference, then all of the records that have no value in the column will be excluded, and we don't want to do it. Here is a summary on the quality of the column AQS preference. The data quality is not very good. As we can see, many records have no value in this column. We may want to fix this problem. In this example, we want to calculate the average order quantity using the aggregate function AVG. When we use an aggregate function such as average, then the result will have the same data type as what the original column has. As we can see, we are calculating the average order quantity. The original column has the integer data type, so the average or the result has the integer data type as well. We got a 34. It would be nice that we get a more precise average. There is a trick that we can use. We can add 0.0 to the original column. By doing that, we convert the integer data type to the decimal data type. Then we run the query again. We get a more precise average, 34.156. So this is a very, very useful trick. In the real world, very, very often, we need to prepare SQL data to be consumed by another application. A common requirement is that the data table cannot be very large. A very large data table causes all sorts of issues, such as performance. In this example, we want to split a very large data table into smaller data tables so that the application can properly consume the SQL data. The original table had roughly 2 billion records, and we will split the large table into many smaller tables, 30 million records each. In this SQL statement, we use select top 30 million into a new table. So we are creating a smaller table now from the original large table. We use a field split to indicate whether a record in the original large table has been used to create a small table or not. If a record has been used, we do not want to reuse it so that we can avoid duplicates. Once we create a small table, we want to update the original large table to indicate what records we have just used so that we will not reuse them. And we update the split field. One could indicate the first smaller table, and we want to join the original large table to the newly created smaller table so that we know what original records we need to update. Again, we update the field split. It's a flag, and one could indicate the first smaller table, two could indicate the second smaller table, and so on and so forth. And this is very important because the split field can tell us whether a record has been used, and we don't want to include any duplicate. This is a very useful technique. There are some other ways that we can use to split a large table into smaller tables, but this is probably the most efficient way to do it. In this example, we want to delete some records from a table, and we do a simple join to filter out the records we want to delete. Also, we use the in operator and a subquery in one of the conditions. This really demonstrates how we could use what we have learned in the real world to help us do the real production work. The links here provide additional information about what we have just talked about. This concludes the lecture on some real-world SQL examples.